Hello, it's Claudio. In this video we will look at Enumerate in Python. Enumerate is a Python built-in function that not all developers know about. It can be quite useful to simplify the way your programs are written. Before looking at how Enumerate works, we'll have a look at Python loops written in two different ways, and then compare how the code changes with Enumerate. First of all, I create a list with 4 elements, and I want to go through each one of them, and also print the index for each element in the list. Version 1 of the loop will be a basic for loop in Python that looks like this. As you can see, in order to print the index for each element, we have defined an index variable outside of the loop, and then we increase its value at every iteration. And here is the output. It's not so bad, but using an index like this can become confusing if you have multiple indexes to manage for multiple lists. Let's move to version 2. In version 2 of our loop, we will use the range function. The Python range function has the ability to return a sequence of numbers. Here's how. For example, here we are using for x in range of 6, print x. And the output is a sequence of numbers that goes from 0 to 5. So how can we apply this to a for loop to print its elements and the index for each one of them? We use the range function to generate the indexes of the list and then use those indexes to access each element of the list and print it. The len function that you can see when we write for index in range len countries returns the length of the countries list, that in this case is 4. And the output is the following. So as you can see, the output is identical to the output of version 1 of the loop. In this case, we don't have to keep track of the index with a variable defined by us, but I'm still not a huge fan of this syntax. Something better is possible in Python. Now it's the time to see how Enumerate can simplify the way we can write the for loop. To understand what Enumerate does, we need to see first what it returns when applied to a list. So as you can see, we are getting back an Enumerate object, but it doesn't really tell us much. What's inside this object? Let's see what happens if we convert it into a list. We have a list of tuples where the first element of each tuple is the index, and the second element is the element of the countries list. So it looks like Enumerate automatically tracks the index for each element in the list. How does it help us with our for loop? As you can see, with a for loop, we can go through each tuple returned by the Enumerate function. What if we want to track the index in the same way we have done in the other two loops? Here is how you can do it. This time you can write for index, country in enumerate of countries. And then you print index and country at every iteration. And the output is identical to the other two versions of the for loop, but with a lot cleaner syntax. Enumerate also accepts a second parameter that is optional. The second parameter allows to decide which number to start the counter from. If the optional start parameter is not present, 0 is used by default. That is basically the way we've used the enumerate function so far. I will change the for loop to start the count from 50. And as you can see, the indexes are now 50, 51, 52, and 53. So this is the enumerate function applied to lists in Python. What else can we apply it to? The enumerate function is applicable to iterable objects. And another iterable data type in Python is the tuple. Let's convert the countries list into a tuple by changing the square brackets into round brackets. And then we can use the enumerate function in a for loop. Pretty simple, so it worked in the same way as it worked with lists. In Python you can also mix different data types. For example, we can create a list of tuples and store a country and its capital in each tuple. Then we use a for loop to print the index for each tuple and the capital for each country. Here you can see the syntax that we use to access elements of a tuple. So let's see how we can write a for loop using Enumerate to go through each tuple in this list. Notice the syntax we are using to print a string that contains variables. %d is used to print a number, the index, and %s is used to print a string, the capital and the country. So what other data types can we use Enumerate with? I'm wondering if we can use it with a Python string. At the end, a string is just a sequence of characters. Let's give it a try. It works. As you can see, the enumerate function allows to track the index for each character in the string Italy. So what other data types can we apply enumerate to? Can we apply it to sets and dictionaries? To understand if enumerate can be applied to sets and dictionaries, we have to make a step back to data types in Python. The ordering of items in sets is arbitrary, and also the order of keys values in dictionaries is arbitrary. The same doesn't apply to strings, lists, and tuples that maintain the order of their items. So a sequence in Python is a data type that maintains the order of their items. Let's verify which one among strings, lists, tuples, sets, and dictionaries is a sequence with a simple program. In the first line, we import the sequence class from the collections.abc module. ABC stands for Abstract Base Classes and is something I will cover in a different video. The function isInstance that takes object and class info as argument is a built-in function that returns true if the object is an instance of type class info. We want to use this function to understand if our objects are of type sequence or not. This little program confirms that only strings, lists, and tuples are sequences. So retrieving an index for sets and dictionaries doesn't really make any sense. Once again, as mentioned before, the order of items in sets and keys and values in dictionaries is arbitrary. So how do we iterate over sets and dictionaries? We can use a simple for loop to do that. Here is how you do it with a set. As you can see, when I print the element of the sets in the for loop, they are not printed in the same order in which they were added to the set. This is another confirmation that items of a set are unordered. The interesting thing is that I can use the same identical for loop to print also elements from a list or a tuple that contain the same items. So here is how we do it for a list. And if I now change the list into a tuple, I can run the same code to print the element of the tuple. You can see why Python is quite cool and also easier to learn compared to other programming languages. You can apply the same construct to different data types. And finally, let's have a look at how to use the for loop with a dictionary. In a dictionary, every item has the format key: value. Now that we have seen how Enumerate works, we understand why it's a lot easier to write a for loop using Enumerate if we need to track the index of each item in a sequence. But now I want to know which one of the ways of writing a for loop is better in terms of performance. I will compare the three implementations of the for loop using a Python module called timeIt. The default number of executions for the timeIt module is 1 million, and I'm gonna keep the default. So let's have a look at version 1 of the loop first. Here is how you modify this code using timeIt and print the total duration of the test. I'm replacing the print inside the for loop with a couple of other commands, so that I don't have to print a million times all the elements in the list, and I can just print the total duration of the test. And here you can see the total execution time for version 1 of the for loop. Let's move to version 2. Version 2 is the version of the for loop in which we were using the range function. Let's modify the for loop in the same way we have done with version 1, so it can run with the timeIt module. And here you can see the total execution time for version 2 of the for loop. And finally we test version 3, the version of the for loop that is using the enumerate function. As you can see, based on the execution time, version 3 of the for loop is the fastest of the 3 implementations. This is something to keep in mind when you decide how you prefer to write your for loops. In conclusion, in this video, you've learned the traditional way of writing for loops in Python, how a for loop changes with the enumerate function, how to use a start index different than 0 with enumerate, how to apply enumerate to lists, tuples, list of tuples, and strings, why enumerate doesn't apply to sets and dictionaries, and finally how to measure the performance of for loops with and without enumerate. And you, which way of writing a for loop do you prefer? Version 1, version 2, or version 3? Also, will you be using the enumerate function in your Python programs? Let me know. And also let me know if you have any questions, just write them in the comments below. And if you want to learn more about Python programming, hit the subscribe button and you will get notified every time I publish a new video. Thank you for watching and see you in the next video.